For the next circuit we will build, we will explore digital logic and build an AND gate using LEDs and buttons. To start, you will need the following: one breadboard, power source, one 7408 integrated circuit, two push buttons, two 68K resistors, and one 4K resistor, one LED, and various jumper wires. Step 1 is to connect the power source to the breadboard. Step 2 is to place the integrated circuit into the breadboard across the break. Use caution not to bend any of the legs and ensure that the notch is on the left side. Step 3. Connect VCC to the positive power rail and also connect GND to the negative power rail or ground. Step 4. Place your two buttons to the left of the integrated circuit across the break and the breadboard. Step 5. Place two wires, each from the positive power rail, going into the left side of the button. Step 6. Connect the output of each button to the first and second input of the integrated circuit. Step 7. Connect your 4K resistor from the negative power rail to the right side of the integrated circuit. Step 8. Connect your LED with the negative leg connected to the resistor and the right positive leg to the left of the resistor. Step 9. Connect the output of the AND gate to the left or positive leg of the LED. Now your circuit should be done, and in theory, this light should only turn on when both of these buttons are pressed. However, we can see that no matter what we do, the light is on. AND gates typically require both inputs to be on to output a positive signal. We can notice that even if I click one button, it stays on. This brings us to an important lesson. When the button isn't pressed, there is no signal to the inputs. The lack of signal is hard to read because it's looking for a positive or a negative signal to determine if it's a true or false input. Usually it will assume a positive signal when no or very little signal is applied since the input is floating. The way to fix this problem is using what's called a pull-down resistor. A pull-down resistor uses a high resistance to apply a small negative signal to the inputs instead of leaving them floating. This is like grounding them so they can provide an accurate signal. Let's place two resistors at the inputs of the AND gate. By placing two pull-down resistors on the output of the button, those two wires using the orange wire are connected to the inputs of the AND gate. Now we can see that the light turned off and it only turns back on when I press both buttons. And this accurately represents how an AND gate should function. Various integrated circuits have different internal diagrams. However, the 7408 used here, the diagram shows 4 internal AND gates. We connected to the bottom left one with 2 inputs from the buttons and 1 output leading to the LED. I'd recommend trying out various integrated circuits so you can learn how they work, and remember to always use pull-down resistors to ensure accurate outputs. These logic gates will be used in future projects, so it's important to understand how they work. Thanks for watching, and I'll see you in the next build.